Okay, guys, my name is Jim Ridwan. I'm a student of University of Ilorin, computer science student. So today we are going to talk a little bit about ML, machine learning. So machine learning 101. So let's get started already. So we are going to check introduction to ML and we are going to follow some topics like definition of terms, differences between ML and conventional programming. Oh, a mistake. Misconceptions in ML, applications in ML of ML, and probably how to get started in ML, and a question and answer section if you have time. So definition of terms, we are going to define artificial intelligence, machine learning, and deep learning. These three terms are always intertwined and only few people know the difference between them. So let's start with that. If you have any question, switch on your mic because I can't check your messages while I'm presenting also. So artificial intelligence. Artificial intelligence is a field that tries to incorporate human intelligence to machines. Whenever a machine is able to complete tasks without any external help, that's very important. When you are when a computer is able um to do a task without any external help, native to humans, that means a skill that is native to human. Normally, humans can work. Computer although we have machines that can work like vehicles, but it still needs human help to work. So what if we now check self-driving cars? Self-driving cars has no driver, but it moves. So that's a kind of AI for you. A normal car is just a normal machine, but when you come to self-driving cars, that is an AI machine or a AI device. So, and I give an example of identifying colors. Machines can identify colors. At least with normal programming, they can't identify colors. But with AI, machine can identify between blue and green. Somehow, it's not as if it knows it, but at least if you point it to it, it will be able to identify between blue and green. And this is not possible with what's it called? The normal programming we know, the normal the normal loops, the normal if else statements. That cannot be possible. But with AI, we can do something like that. Now, machine learning. Well, let me say something. Okay, let me just leave that. Machine learning is a subset of AI. Machine learning AI, though they are used together, but they are somehow different. AI can be seen as the superset of ML and also deep learning. AI is the one that encompasses everything. Don't worry, I'll still show you a picture of something like that. So machine learning is a subset of AI that uses statistical processes to make machines learn by themselves, given the provided data and make accurate decisions slash predictions. It may be a decision or a prediction. They are it's still somehow the same, but they are a little bit different. So machine learning is a task or it's when it's a statistical process that allows machines to learn by themselves. And how do they learn by themselves? They achieve this by learning from previous data, not so when you want to build your machine learning model, you have to learn from previous data. Now with statistical tools, you can be able to detect patterns. The machine can be able to detect patterns in this data. So with that detection of pattern, it can use it to what's it called make further decisions on new data. It can make predictions, can make decisions on new data. So as I said there, once the model has established patterns from the training data, it can be exposed to new but similar data and still be able to make accurate decisions. And when a machine learning model can see new data and still be able to make good decisions on it, it is termed generalization. That's the thing we use in ML when a machine works very well. There are some bad models that won't. Once they see new model, they will fail. That's either underfitting or overfitting. But we aren't going to that. So we have deep learning. Deep learning is also a subset of ML. That means it's also a subset of AI. Deep learning is just ML. It is machine learning, but a new field, and a very new field in machine learning that is growing very, very, very largely. So deep learning is a kind of machine learning model that is inspired by how human brain works. How the human brain works is what inspired deep learning. So it follows the pattern of how the brain filters inputs to see similar occurrences with past events. It follows how the brain works. So they modeled this kind of process or this kind of algorithm so that it can be able to follow how the brain works, how our brain filters information, how we can remember things very, very well. So that's what deep learning goes. There are many examples of deep learning like neural network, artificial neural networks, and so on. So why I say this deep learning model is new, it's somehow new, and it's even possible now because of the advancement in technology. For you to run a deep learning model, you need a very, very good machine. Don't worry, I'll clear that out later. You need a very, very high-end GPU. So for you to be able to run any deep learning model, you need GPUs because it works on very, very, very large data. And large data like images, they usually use them for images and speech, other things also, but this is where deep learning is having an upper hand. You can also use other algorithm, machine learning algorithm for images and speech, but deep learning has proved to be very, very useful and better than others. So we use it very well in image and speech related problems. So from what I've said, we can see that, let me increase this a little bit. Okay. Artificial intelligence is the superset of all. And from what is written here, I hope you can see it. It's very tiny. Sorry about that. Any technique which enables computers to make decisions. That's what AI is. And for machine learning, we have that. I can't even say it myself. Gosh, S- I can't see it. So we all know that
I don't know. Maybe you
intelligence is
can
the superset of
turn to
everything.
landscape.
Artificial intelligence cannot work on its own without machine learning. And artificial intelligence is not only about machine learning. For you to create a self-driving car, you still need software developers. That's not part of machine learning. That's a normal programming. So you still need other aspects to make an AI system. So, but when it comes to machine learning, you do not need much of normal programming because oh, you don't need much of normal programming because you just deal with statistical models and so on. Same with deep learning, though you still need normal programming in doing your object-oriented stuff, but it's not as much as artificial intelligence. So the difference between ML and conventional programming. Now, for us to understand the difference between them, let's just look at an example. I hope you can see the image. The problem here is predicting the prices of buildings based on their age. Predicting the prices of building based on their age. So how will we do this? How can normal programming solve this? A conventional programming, how can it solve this? If you look at the image very well, we can see patterns in them. Maybe you want to solve it with normal programming. You can see patterns in them. We can see that as the age of the buildings increase, the price of the building decreases. Now the price of the building is in million naira. So we have 28 million, 22 million, and so on. But if you notice, the one of 13 years is 20 million. But when you check a building that is as cheap as that is new, 1 year, you have 35 million. You can see that as the price of the as the years as the age of the building increases, the price decreases. Now we've noticed this pattern, but what can it still do? What can normal programming do? If you try to do 28 divided by 6, we'll get and we do 22 divided by 12, you'll notice that this stuff is not constant. Maybe we should just do something like x equals mx. You can't get it because the changes is not constant. So you'll be stuck with that for a while because you can't do normal programming for it. And if you, even though if you want to execute it with it, you take a lot of time. But there's a model in machine learning called linear model. It is one of the simplest model in machine learning, and it can do this very efficiently. We will be familiar with this equation: y equals mx plus c. That's the equation of a straight line. So with this, we can solve this question very, very well. So the first thing we have to do is, though this is not necessary, but at least let's visualize it. You have to plot everything. And I forgot to say, that's just a tip of the iceberg of the data. The data is actually 200. I just showed the first 200 so we don't get confused. So this is all the data. Though I formed them though. Now you can notice that there is a correlation between price and age of building. That's what linear models are. Without correlation, linear models can't work. So you can notice that there's a very strong correlation between the price and the age of buildings. Now, what if we want to predict, since we've plotted everything, what if we want to predict other prices? We have to find a straight line as the equation says here, y equals mx plus c. Now there's a way we get to this, because I don't want this class to be much of coding, but much of you learning what machine learning is. So we just, maybe let me say 2 lines of code. You can get the equation of the line here. And when we get it, it will be something like this. Now with this, we've been able to fit this model very well. The model has been able to train and understand this pattern, understand this data very well. For it to get this, it is by, let me say, somehow by trial and error, it will try to fit and find the best straight line that covers all the data. And you can see with this line, I don't think there will be any better line to cover all the data. Now, if you have new inputs, new buildings, and we know their age, like here we have 32 and 35 years old building, we can be able to predict their prices very simply by doing what? By just tracing it to the line and tracing it to the prices. You see that this you'll be able to get a price. Though I told you I formed this, so you can see that we are getting something like -4. I didn't even notice when I was forming it. So I formed this data, so there should be errors. But I hope you got the, what's it called, the knowledge from here. So with this, we have been able to predict future events. Though this is very, very simple, and real life data can be like this, but this is just the scope of it. And when you have only one future here, which is age, there can be many futures like the area the building is, and so on. So the features may be up to 10 or so. And we only have one feature, and normal programming is still trying to solve it. What if there are more than one features? Like I said, that means we can't view it, because once we add another feature, it will be three-dimensional. That's still maintainable. But when you get to three features, that's four dimension. How will you plot four dimensions? How can your brain think of how to use normal programming to solve that kind of stuff? So it is almost impossible. Of course, normal programming works in a lot of things. At least it works in a lot of things. You can use it to create apps, you can use it for a lot of things. But when it comes to things like prediction, fault detection, it can't work, because there are many things to consider that normal programming doesn't consider, except for machine learning. I think I'm super fast too. I'm not going with the side. So some misconceptions about ML. With every field there will be misconceptions. So let's clear some of them. Okay. AI and ML seen as hardware. AI never operates on its own, likewise ML. They rather be a part of a bigger machine. For instance, Robots comprises of AI and Arduino. Autonomous cars are made up of AI and mechanical parts. I've explained this earlier that AI doesn't stand on its own. It doesn't need only ML. You still have to program the stuff like the machines to use, the how to create an app for the self-driving car. So there are a lot of things to consider. So AI doesn't stand on its own. It's not an hardware on its own. It's we can call an AI system. That means that's an idea,
Uh,
but AI doesn't
sorry.
stand on its own like that. It needs other skills for it to stand on its own. Now, taking ML to be AI, I hope I've cleared that part already. Though they are used interchangeably, but ML is a subset of AI. ML takes data, process with algorithms, and return probabilities for AI to think intelligently. I don't think I need to spend much time in that. Okay. Claims that machine learns autonomously. So somehow true, somehow not true. Of course, when you build your AI system, when you are done with the AI, you don't need anybody to operate it again. At least you'll be free. You know it can work on its own, but you still have to maintain it. And we even build those AI systems. It is we programmers that built it, engineers. So it is not autonomous. It can't. It still needs supervision to some extent. Like Google, some of their models they use on search engine, they rerun them every day. They retrain them almost every day. So that's what it means by machine learns automatic. That machine learning doesn't learn autonomously. You still need the programmers to do some stuff on it at least at intervals. So believe that ML AI will take over jobs from humans. Of course, it has started taking over jobs, but at least it's created more opportunities. Though it took some jobs, like let me give an example of nothing is coming to my head. I can't think of okay, I can't think of anything. Let me read this. As it said, there will be need for ML experts, data experts, and all since production will increase and increase in demand for humans with technical know-how. So then unskilled labor will be on the rise too. So ML will attain human level natural intelligence. This is not, I can't say it is impossible. I can't say it is not possible because science has always surprised us, but at least not in the next 100 years. It can't even do that. It can't attain human level intelligence. At least if it does, it's not in this century. That can happen. So algorithms as magic wand. It's true. You can see many images online about how AI looks like. Some it will just be a robot and it will be doing a lot of things. You've seen it in films, iRobot for example, where machines almost took over the world or something like that. But it's not possible. It's not a magic wand. So applications of machine learning. Now we are going to just look at some applications of machine learning. So traffic alerts in maps, for example, Google Map. If you are conversant with Google Map, you can notice that when you want to, maybe you want to use the Google Map to navigate roads, they may show you delay some in some places, and they may show you that this is the best possible route because there's a traffic jam somewhere. So this is possible with AI. Even Google Maps alone is AI on its own. Social media, Facebook. Facebook uses detection and image recognition to automatically find the face of the person, which matches its database and hence suggests us to tag that person based on deep face. Now, it's not only Facebook that use face detection. I even see it. I think the most advanced is Google Photos. That thing is amazing. It groups faces for you, and you just have to name them. So we use face detection. Facebook use it. Almost everything uses it. Your phone has it also. Some of us unlock our phones with face detection. That cannot be possible with normal programming. It needs AI. It needs to learn from previous data. So transportation and commuting. So to detect your location and provides option for either go home or something like that. Transportation and commuting. And we have another example. Uber has self-driving cars also. So an example of this transportation and commuting is self-driving cars, and there are numerous apps that helps you prevent traffic, but that helps you not end up in a deadlock because it would have prompted you already, either based on previous data that there is always a traffic jam here. You won't have to pass there. You have to find other routes. So these are the things AI can do for you. A product recommendation, there are lots of examples on this. We have Netflix, we have Google. When you search for stuffs, you notice you get ads also, and you notice that this ad suits you very well. As in, if not that you don't have you don't have money, you would have bought them. So this work of AI. Same with Netflix. You see amazing. You are done with one video and you see amazing suggestions for you that you make you almost spend all your money. And we have virtual personal assistants like Siri. We have Google, okay Google, we have which one is we have Bixby for Samsung. This is possible with AI. Sometimes I spend time just talking to the, though not so excellent, but at least it's progressing. I spend time talking to Google and it's very good. And that's not the only place you can use it. There's when you call customer services sometime, it is AI that is talking to you. It is not humans. They may ask you for codes. All those things are AI. Though this is not very advanced in Nigeria, but at least if you call, I can say for banks, you call banks, you lost your card, all those stuffs. It is AI that is most times talking to you that will tell you to insert something and so on. So that's virtual personal assistant. And some businesses use it also. When you open some site, you see you can chat with me here. Some you have chat options, you have voice options where AI will talk to you. Now, image spam and malware filtering. Do I hate this stuff? I hate it. It spoils my mails. It spoils my mail for me. I don't know whether it's not advancing anymore. It doesn't does the job for me. But your mail use AI to filter spam from real mails. I hate Google for that. I don't like it. It doesn't does the work very well, but it's very possible. Now, online fraud detections. Now, there are many ways to prevent fraud. Maybe by yourself, you can prevent fraud, protect your details and so on. But there are some cases that is beyond you, and your banks can help with that. There are AIs to detect fraud, and the major data they use are the times the transaction occurs, um, the amount of the transaction, and so on. With this, they'll be able to block the transaction and inform you whether the transaction is true or not. Though it may be wrong sometimes, but at least they've stopped something. And if it is wrong, you give them a feedback that this was a false alert. And if it is right, you'll be very grateful that they blocked the transaction from happening. Now, automatic language translation, we have Google Translator. That's even simple because it uses text. There are some translation. I think Google also uses it. You can speak to the microphone and it will translate it to different languages for you. I've seen some apps on it. So I didn't care to know the name because I didn't need it. Especially when I'm watching YouTube, I see many adverts on translators. Like I can translate from English to German and so many languages like that. Now we have medical diagnosis. AI is also very useful in medicine. Sometimes we use AI to detect diabetes. For the normal project, everybody in AI would have done that kind of project. Detecting cancer cells from non-cancer cells, malignant from benign. So that's just an example of things that AI can do. So let me just read this. In medical science, machine learning is used for disease diagnosis. With this medical technology growing very fast and able to build 3D models that can predict the exact position of lesions in the brain, can see how advanced it is. They use AI to predict lesions in the brain, tumors in the brain, and see the exact positions. There are so many places that AI works in medicine. I've talked about cancer, X-rays. There's what's it called? They use AI to assess your X-ray to know what is wrong because the demand for all these stuffs are in the rising and humans can't catch up anymore. So we need an automated process to make this easy. So it will be able to check what is wrong with your X-rays, whether it's the bones or something, and it will give it. It won't go directly to the humans. It will of course go through experts. Anything AI in medicine is not trusted yet. They still have to filter it to an expert to confirm whether it is right or not because medicine is a very, very critical field. There are errors in machine learning that shouldn't happen. So they still have to take it to an expert. Now we have the last one, self-driving cars. Very awesome. I feel very amused when I see this always. It is very, very awesome. And a big company that is investing a lot in it is Tesla. Though that's not coming to Nigeria anytime soon, but you should be excited about it. So how to get started? We've seen some beautiful slides, maybe not so beautiful. So how do we get started with machine learning? So you need linear algebra and calculus. This didn't send you away. I'll prove that later, but you still need linear algebra. You need your vectors, you need calculus, you need differentiation, you need all those stuff to start. You For me, at 100 level, I was able to learn enough linear algebra and calculus. Even as as an SSP student, you should be able to have enough knowledge of AI based on linear algebra and calculus. So you shouldn't be afraid of it at all. It's not as if you need a PhD degree in mathematics and statistics for you to start. But at least you need to know a little bit of it. Maybe when you're advancing in AI, you learn more. But for everything not to look strange to you, you should just know a little bit of them. Now, you should learn how to code, of course. Now, you shouldn't learn all this for. I just wrote it there. Those are the examples of programming languages used for AI. We have Python, we have R, we have Java. Let me check. Let me see how many of us are here. So we are still five. Wow. Okay, let me continue. So we have these are the programming languages. There are a lot of them that we use for ML, but these are the common ones. I didn't even write MATLAB. MATLAB is also very common, though it's not free. Python, R, Java, and C++. And these events we are going to go through Python. It's Python that we are using because it is the most common one, followed by R, and it is very, very easy to learn. Now you need that database knowledge, though not immediately. You may you may not use database because you may not be the one sourcing for your data, but at least you should have a little knowledge on it. And when you did it later, it won't be a problem. You should have knowledge on SQL, how to manipulate database, how to merge, um how to pivot and all those kind of stuff. You still need a little bit of it, not much at all. Even programming, you don't need much programming knowledge as for normal as from conventional program as in when you want to get into Android development, game development, you don't need much depth in that. You because we don't usually use much of OOP, at least when you are forming the model. Though when you want to design everything, you may need OOP, but not that much. So have a clear learning path. This is a very crucial part because there are a lot of resources on ML. I can't say not all of them. I can't say they are not good, but some of you don't need them. Or sometimes you may even go through the same. You'll go through a course and you won't be able to get anything from it. So you have to have a very clear learning path. Seeing any videos and watching it, or seeing any resources and reading it, you just make you jack of all trades because there are many aspects in machine learning. We have deep learning. We have what's it called? We have NLP. We have speech recognition. We have computer vision. Machine learning is very field. It's very wild. So you have to find a path you have to follow. Maybe you want to invest in what's it called? Image recognition. That's a very large field, and you can follow that path. And if maybe you want to be involved in finance, though it may take a lot of time before you find out, but you should know where you are drawn to. When you want to invest in finance, that is fraud detection, um, many other things like that. So you have to have a clear learning path. It is better you register for courses. Maybe before you start ML, you Google it and you check everything you need. You know the parts, you've read the jobs that are in AI, and you follow a learning path. Now, learning is not when you're learning and you don't practice, you won't get anything from it. You end up forgetting some things. As good as our brains are, we usually forget something. It's not as if it leaves our brain, but because of the many things we see every day, we forget something sometimes. So when you participate, when you work on ML competitions, and there are lots of it, there are lots of it. On Kaggle, it's almost every day that I'm not sure, shall we? Let me say it like that. It's almost every day that new competitions come out that you can register for. We have seen there also, and we have analytics video also. This is where you can see competitions that you can use to test your skills. Now, ML competitions, that's not the only one there. We still have machine learning projects. There are lots of projects you can participate on concerning machine learning. The speech recognition, you can do a little bit of it, though that will take a lot of time, but at least you know you are learning from it. You learn from your mistakes and all sorts. Now, I have don't be intimidated because the hype surrounding machine learning is very high. And when you tell some people that, well, I want to start machine learning, they will say, hey, Baba, all those kind of stuff. Like, we have two brains, but don't get intimidated by ML. You can start, and you'll see that it is not that different from the normal programming knowledge or the one you just want to build on. It is not too different at all. So I listed some points here like you don't need a PhD in stats, maths, or computer science to start ML. An SSC student can anybody can start ML. Don't let me even grade it at all. Anybody can start ML, and there are reasons why this is possible now. There are well-defined libraries that you can use to get started. There are lots of libraries. Pandas, it is used for data manipulation and all those stuff. SciPy is used for data manipulation. SciPy is mostly of statistics. You see more statistics formula in SciPy. Now you have scikit-learn it's a library of models you can use. You can create your model yourself, but I wouldn't advise you to start like that. But there are predefined models in scikit-learn where you can use them to build and see the difference when you use different models on different data and how well they perform. Now we have PyTorch for deep learning and NLP and such. You can use PyTorch for that. No, wow, sorry about that. Okay, let me go. Sorry. So we have a question and answer. We are almost there. So you don't need. I'm done with the libraries you need. You don't need high-end system to start ML. Let me give an example. Deep learning. Not all of us can run deep learning models on our system. My system can run deep learning because you need the latest GPUs, NVIDIA GPUs, not even AWM. What's the other name of this GPU? AMD GPUs. You need good NVIDIA GPUs to run ML. Some AMDs can work, but what major people use is NVIDIA CPUs, in NVIDIA GPUs, high ends for you to run it fast and reliably. So but you don't need them. You don't need them. These big companies have made life very easy. Google Colab, you can use it to run your NLP projects, your deep learning projects, because they will give you it is cloud based. They will give you some allocations of RAM, some allocations of GPUs that you can use to run this model, and it doesn't cost much. Some are free. The ones I listed here are no, not all. AWS is not free. Azure is partly free. So we have Kaggle also. It has its own Jupyter notebook you can use to run models. Wow, I don't even talk about Jupyter notebook at all. Unnecessary. So Google Colab, Kaggle, AWS, Azure, you can use these to run your models. And it is even better because it will be faster and it's free. What else? So and when you have made maybe what's it called? A very large project that maybe the Google Colab allocated RAM and GPU is little for, there are some um servers that you can use to do stuff that are very cheap, very very cheap. So don't be intimidated by you not having good CPUs. That TB systems run machine learning models. You can use that to run models. So there's nothing to be afraid of about not having high models. But big companies have made life easier for you and it's free. So what else? Now I think I've done with everything and we are in question and answer session. If you have any questions you would like to ask,
Thank you very much, Jimo. Jimo would like you to ask any questions you might be having. So if you have any questions, you can easily ask him now.
so I'm awaiting questions.
Okay. So while we wait for people to ask questions, so I'm just gonna say some a few things. So thank you everyone for joining this meetup. There was some people came late and some people were available from the beginning to the end. So thank you very
Balls.
much. So this is a maiden event. Yeah, one the first event out of all events that we'll be organizing for machine learning study group. So
This is
we
interesting. I
mainly
think I should stop
targeted
presenting.
this event to
Maybe
introduce
I should
you
leave
all
it.
to machine learning, and I think we have basically done that. So around this session will be it will be available for
Okay,
on
guys,
YouTube
questions.
for
If
you
you have
guys
questions,
to watch after. So if you feel you still need some insights as to what machine learning is, okay. We started a machine learning study group on Monday. So we closed registration earlier on, but we have decided because we saw that so many people have decided to also join the study group. We decided that okay, we should reopen registration for the study group. So basically, what we do in the study group is that
since we
we
don't have
learn
questions, I
together.
think I should talk a little bit about how these.
We make use of the resources
I don't
that
even know what
we
to
have,
term it.
and
What boot camp
we
or
learn together and we share ideas.
this
So
10 week long tutorial will go.
okay,
We've
let me
already
continue.
what's it called? Suggested a course we'll follow. It is a Coursera course. It is not a free course. It is not a free course, but you can audit courses on Coursera. And apart from that, we have some exercises that will help us throughout the courses. So once we drop the exercises like every week or maybe every 2 weeks, that will be able to that you will use to examine how where you've learned. And there will be meetups also. Weekends like this, we'll meet up and we talk about what we've learned, where we are lost, and so much more. So we have a course. It is let me remember the application of applied machine learning by University of Michigan University, and it is very very good course. So if you would follow that course, I think you get some good knowledge on AI, and you
Okay. Thank you very much, Ridwan. So like I said, we are hosting a study group. So if you feel like joining the study group, machine learning, I'll drop a link in the chat box where you'll be able to register for the study group, and you'll be able to meet with people like you that are interested in learning machine learning. So machine learning is a very good thing to get into. So I've shared the link to the registration in the chat box. So like I said, this event will be available on YouTube if you want to watch the recording. So I'd like to end this call on a very interesting note, which is to say a very big thank you once again to everyone. This has shown that you're really passionate about machine learning. You want to learn and develop yourselves and anyone around you. So a very big thank you to you. And this is just one of the ways we can interact. We can also interact on the study group or on the general university, the DSC University of Ilorin WhatsApp group. So if anyone doesn't have any question, we should be able to end this call and have a peaceful and amazing weekend. So if anyone has any question, you can ask. We still have a little bit of time left for you to ask questions. Okay. Yeah, I would assume no one has questions, and I would like to end the call. So I'll thank you everyone and have a blissful weekend.